Hello, sir. My name is Jasmine Kaur Batra. Me, along with my group mates, Karthik, Anup, Prathamesh, and Vaishnavi, are going to represent the topic named Sign Language Gesture Detection System for Dumb and Deaf People. Communication is a fundamental need for an individual. People interact with one another to share information, opinions, feelings, but the most important aspect of communication is that it makes people feel connected to one another. Due to their lack of understanding of the sign language used by deaf, normal people find it difficult to communicate with them. So, our problem statement include the main aim to develop a real-time machine learning system that can accurately detect alphabetic hand gestures of sign language and translate them into corresponding English letters. This system aims to bridge the communication gap between dumb and deaf people who use Indian Sign Language as their virtual communication medium by providing the reliable and efficient method for translating the hand gestures. First, we will train the model using the given script. This script is designed to capture the frames into the webcam using the OpenCV library and save them in different directions based on the key pressed on the keyboard. The script performs the following steps. Important necessary libraries, the scripts. Start by importing the required library OpenCV named CV2 and OS. Initializing the video capture. It opens the default camera index 0 using CV2 video capture and assigns it to grid cap variable. Define the image directory. The directory where the captured image will be saved is specified as image and stored in the directory variable. Now, I would like to hand over to Prathamesh to continue with the further code.
Thank you, Jasmine. So after that, we will count images in each letter directory. Basically, it counts the number of images in directories A to Z and stores the counts in a dictionary called count. This count is used to generate different file names for the captured images. After that, we will create a region of interest, that is ROI, which is basically a rectangle in the captured frame as a region of interest using CV2 rectangle. This region of interest will be displayed on the screen and you can capture images within this region. After that, we will display the frame and ROI. The captured frame and the ROI are displayed using cv2.iamShow. After that, we will wait for a key press for 10 milliseconds using cv2.waitkey. This allows us to press a key to capture an image. After that, we will save the images based on key press. If a key is pressed and it corresponds to a letter from A to Z, the script saves the ROI as an image in the respective directory. It generates a unique file name for each image by counting the images already present in that directory. At last, in summary, this script captures images from the webcam and allows you to save them in directories corresponding to the letters of the alphabet based on the key pressed. This can be useful for collecting training data for various machine learning and computer vision tasks, such as building a dataset for recognizing handwritten characters. So I will hand over to Vaishnavi.
So, hello, this is Vaishnavi. Further, the data.py files explains the about the data collection process for a training machine learning model for hand gesture recognition using the key information. In that, the first point is create a directories. The outermost loop iterates over a list of actions. For each action, it creates a directory structure to store the data. Nested loops are used for the sequence, that is a number of sequence, and the frame num, which is a sequence length, and these loops are used to structure the data collection process, where each sequence represents a set of frames capturing a specific hand gesture. The third point is the data collection loop. The code enters a loop where it iterates through each action. For example, the specific hand gesture, the sequence, which is a set of frames for that gesture, and the frame num, which is each frame in the sequence. Then the read frame, instead of the capturing frames from a live camera feed, it appears to read the frames from image files and it loads an image using CV2 IAM read. Then media pipe hand detection. In that, the loaded frame is passed to the media pipe hands model for hand landmark detection, and the detected landmarks, that is the key points, are stored into the results. Then the display progress. The code displays a message on the image to inform the user that data collection is in progress, and the data message includes the action.
I will explain the function.py. It is a Python script that utilizes the media pipe library for hand landmark detection and data extraction. First of all, we will import the libraries. The script imports several libraries, including CV2 for OpenCV operations, NumPy for numerical computations, OS for file and directory manipulation, and the media pipe library for hand landmark detection. Further, we extract the key points function. This function extracts the key point information from the detection result. It takes the detection result and converts the landmark into a flattened NumPy array. The resulting array contains the X, Y, and Z coordinates of each detected hand landmark. Overall, the script serves as a foundation for capturing hand gestures, extracting key point information from detected landmarks, and saving the collected data. The script can be extended to create a dataset for training a machine learning model to recognize and classify different hand gestures. Further, I will hand over Anup to explain.
Thank you, Karthik. So the further app.py is a Python script that performs several tasks related to the hand gesture recognition and natural language output. So importing libraries and loading the trained models. The script starts by importing various libraries, including the custom functions from function.py, as well as the libraries like OpenCV named as CV2, Keras, and MediaPipe. It loads a pre-trained neural network model from two files. First one is a model.json for the model architecture and model.h5 for the model widths. So this model is likely used for the gesture recognition. So using MediaPipe for hand gesture detection, it uses the MediaPipe library to detect the hand landmark, that is key points, in a cropped frame. Detected landmarks are stored in a results variable. Key point extraction. So key points are extracted from the results using the custom extract key points function. So this key point represent the hand detected landmarks. Making predictions. The extracted key points are added to the sequence list and only the 30 sequences are retained. If the sequence contains 30 key points, it is fed into the pre-trained model for prediction. The predicted gesture is printed and result is stored. Now we will show the demonstration of our model. The demonstration will be shown by the Karthik.
So now I will show the demonstration. So in the terminal, it shows the output as A. Now, by showing the sign language of C, in terminal, we can see that it is showing C. So that's all about our project. Thank you.